numerical differentiation. What we discuss in numerical differentiation is, suppose if there is a first order differential equation, first order first degree differential equation, if it is like this, dy by dx equal to, for example, say the equation is x plus 2. Suppose the boundary condition is this. This is my initial condition, or sometimes it is also called as boundary condition. The condition is like this. For example, y of 1 equal to minus 2. Then I may ask you, what is y of 3 value? Suppose the question is like this. Dy by dx equal to x plus 2. It is a first order first degree differential equation. My initial condition is y of 1 equal to minus 2. So I need to find y of 3. See, when you solve a first order first degree differential equation, the general solution contains exactly one constant c. To evaluate this constant c, one boundary condition is supplied. What does it mean? When x equal to 1, the value of y becomes minus 2. So once you replace these values, you will get the value of c. And then get the particular solution. After that, replace x by 3, that is required value for us. Now let us see. Let us solve this equation by using normal differential equations, not numerical differentiation. I will come back to this. So here dy by dx equal to x plus 2. So here dy equal to x plus into dx. Y variables are one side and x variables are one side. So go for integration on both sides. Integrate dy equal to integral 2x plus 3 dx plus c. So here y equal to x square plus 3x plus c. Now this is general solution, y equal to x square plus 3. This is the general solution of this equation. Sorry, this is actually x plus 2. The equation is x plus 2. So therefore this is integral x is x square by 2 plus 2x plus c. Now this is my general solution, y equal to x square by 2 plus 2x plus 3. Now here my boundary condition is y of 1 equal to minus 2. That means when x equal to 1, y becomes minus 2. So let us substitute these values, y value minus 2, x value 1, 1 by 2 plus 2 plus c. So here the value is minus 2 equal to, this is 5 by 2 plus c. So c value is minus 2 minus 5 by 2. This is minus 9 by 2. So we can say that this is, c value is minus 9 by 2. Now let us substitute c value here. So therefore the value of c becomes y equal to x square by 2 plus 2x. c is replaced by minus 9 by 2. Therefore this is my particular solution. So it is x square minus 9 by 2 plus 2x. This is my particular solution. Now I need y of 3. So replace x by 3. So 3 square 9 minus 9 0. This is 6. So this is exact value. Y of 3 is 16. My equation is dy by dx equal to x plus 2. This is my boundary condition. Y of 1 is minus 2. So if I solve this equation, my general solution becomes y equal to x square by 2 plus 2x plus c. This is my general solution. So because I don't have a value of c, to get this value of c, a boundary condition is supplied. Y of 1 equal to minus 2. That is when x is 1, y value is minus 2. So substitute those values. I am getting c value equal to minus 9 by 2. Therefore, the y becomes x square by 2 plus 2x minus 9 by 2. This is my particular solution. This is particular solution. Now we need y of 3, replace x by 3, the value becomes 6. So this is the approach we follow normally in the differential equations. So they are accurate methods. Y of 3 is 6, this is 100% accurate value. But in numerical differentiation, what we do is, in this case y of 3 we got it. So there is no restriction on this value. You may ask me what is y of 4. If you ask me y of 4, I will replace x by 4. Boundary condition is same. If you change the value of y at different values, that means y of 1, y of 6, there is no restriction on finding y values at different values of x. So you can evaluate y values at all values of x. So still you will get accurate values. So no restriction on x values. Here we need to find y value when x equal to 3. This is y value when x equal to 3. no matter whether x is 3 or x is any value. You can take x value -2, 9, 1, -1/2, like etc. So no restriction on x values. Even if you do not put any restriction on x values, you can get exact values of y by using differential equation techniques. But in case of numerical differentiation, the problem is same. First order, first degree differential equation will be given. Initial condition will be given. You need to find y of x where x is multiples of specific values. So there are some restrictions on x values. Even those restrictions, because we are getting values of y iterations wise. Here we are getting direct values and they are 100% accurate values. But when you look at numerical differentiation techniques, all these are approximation values. Sometimes you need to find y value in 3 iterations. That depends on certain values I will discuss within few minutes. So sometimes the value of y you need to find in 4 iterations. So how many iterations are required? That varies from example to example. So even if you go through number of iterations, that value may not be accurate value. So we have 2 drawbacks in numerical differentiation when compared to solving equations by using differential equations techniques, right? So one drawback is you cannot find y value at all values of x. Second value, even if you get value of y in third iteration or fourth iteration, they may not be accurate values. Okay. In the olden days, before inventing differential equations, people used to follow numerical approach techniques. Once they invented differential equations, nowadays they were following all this, but olden techniques are numerical methods. Okay. Now let us see how numerical differentiation techniques. So first we go for RK method of order 1. This is also called as Euler's method. So in this we discuss Runge-Kutta methods to solve first order first degree differential equations numerically. So we have a first order first degree differential equation like this: dy by dx equal to f of x comma y. My initial condition is y of x naught equal to y naught. We need to find y of x. And in this case, step size is given. Here the value of h is given and this value is called step size. That means how many iterations are required to solve this question. Sometimes I may require only 1 iteration, sometimes 2, sometimes 10 iterations. So that depends on value of h. That's why it is called step size. So the number of iterations required to solve this problem will depend on h value. So this will be provided: dy by dx equal to f of x comma y. It is a first order and first degree differential equation. Initial condition is given: y of x naught is y naught. So y of x we need to find. H will be given, step size. Here x is nothing but positive integral multiple of h. This is positive integral multiple of h. Let us see how to get this. Here the value of root in the first iteration is given by y0, y1. This is value of y in first iteration. This is given by y0 plus h into f of x0 comma y0. So the value of y in second iteration, this is nothing but y1 plus this is h into f of x1 comma y1. Similarly, the value of y in third iteration, this is y3 and this is nothing but y2 plus h into f of x2 comma y2 and so on. If you ask me what is the value of y in k plus 1 iteration, this is given by yk plus h into f of xk comma yk. So this is the value of y in k plus 1 iteration. Here k values start from 0 onwards. So 0, 1, 2, 3, etc. So this gives me value of k in k plus 1 iteration where k starts values from 0 onwards. Now current value is depending on previous value. So y3 depends on y2 y2 depends on y1, y1 depends on y0. Now, what are unknowns in this equation? x0 is given, y0 is given, but you don't know what is x1, what is x2, what is x3, like this. Now, let us see what is x2. Here x2 equal to, at first I need x1 value. So, here x1 value is x0 plus h. x2 equal to, this is x1 plus h. x3 equal to x2 plus h. Current x value depends on previous x value by adding h. x3 is x2 plus h. Like this, when you ask me what is xk plus 1, this is nothing but xk plus h. Now when you group all these, suppose if I start with the 3, here I am saying that x3 equal to x2 plus h. But what is x2 in terms of x1? This is x1 plus h plus this h. So we are getting x1 plus 2h. But what is x1 in terms of x0? This is x0 plus h. So x1 is x0 plus h plus 2h. Therefore, the value of x3 is x0 plus 3h. So like this, you can easily get value of x4 in terms of x0 because x0 is given. So therefore, if you ask me what is this xk plus 1, this is x0 plus here if it is 3, we are getting multiples of 3. So this is k plus 1 into h. So this is the value of xk plus 1 in terms of x0 and h. So this is the way to solve these equations. But what this y of 1, when you need to end your problem in the first iteration, this is nothing but y of 1h. This is nothing but y of 2h, y2. This is nothing but y of 3h. And so on. Then this is nothing but y of k plus 1 into h. That means, suppose if the value of h is, for example, 0.3. If they ask you y of 0.6, so here the value of x is 0.6, h value is 0.3. This is step size. This is 0.6. So here you write the value of x as a positive integral multiple of h. So 0.6 is nothing but 2 times h. So that means you need to find the value of y in second iteration. So your problem will end in the second iteration. y2 is required. So therefore, whenever h is given, if they ask you to find y of x, you must express x value as a positive integral multiple of h. Of course, this is one of the drawbacks. So when we gone through one of the example at the starting of this session, I asked you to find y of 3. So there is no restriction on x value. X can be 3, 4, 1 by 2, etc. But in this case, based on this h value, you need to find y at different values of x. And those values of x must be multiples of h, and that multiple is a positive integral multiple. So if when h is 0.3, if they ask you y of 0.6, you express 0.6 as a multiple of 0.3. That is nothing but 2h. Y of 2h means you need to find y2 value. That is value in the second iteration. So to get value in the second iteration, you must know the value of y in the first iteration. Suppose if they ask you what is y of 0.9 in this case, but h is 0.3, I am not changing. Then express this 0.9 as a multiple of h, positive integral multiple of h. This is y of 3h. That means you need to find value of y in third iteration. So y3 is nothing but y3h. y2 is nothing but y2h. So always you need to write x value as a positive integral multiple of h. And then you can proceed these values. So therefore, this is called Runge-Kutta method of order 1 or Euler's method. Why it will be called as order 1? Because for every iteration, we are finding this. So at first, we have found this h into f of x0 by 1. In the second iteration, I evaluated h into f of x1 by 1. So for every iteration, one single quantity is required. That is h into f of xk comma yk. So that's why it is called Runge-Kutta method of order 1. After this, we discuss Runge-Kutta method of order 2. That means in every iteration, 2 values are required. And then Runge-Kutta method of order 3. So for every iteration, we need to find 3 values. In case of Runge-Kutta method of order 4, we need to find 4 values, k1, k2, k3, k4. So that's why it is called order 4. What are the benefits if I increase order? So when compared to Runge-Kutta method of order 1, Runge-Kutta method of order gives more accurate values. When compared to that, RK method of order 3 gives some more better value. But when you go through RK method of order 4, for every iteration, you are putting a lot of efforts. That means you are finding 4 iterative values. therefore it gives more accurate value. So therefore, as order increases, accuracy will increase. Okay. So this is the basic concept. Whether it is RK method of order 1 or 2 or 3 or 4, our problem is same. What is my task? Dy by dx equal to f of x comma y will be given. It is a first order and first degree differential equation. Initial condition must be supplied. Step size will be given. Then you need to find y at value of x. First order, first degree differential equation will be supplied. Initial condition will be given. Step size will be given. You need to, they may ask you to find the value of y at x. But this x must be a positive integral multiple of h. So x is a positive integral multiple of h. If it is y of 1h, you need to find y value, y1, that is value in first iteration. If they ask you y of 2h, that means indirectly they are asking you to find y value in the second iteration. If they ask you y of 3h, so that means you need to find y3, that is value of y in third iteration. This index represents we are in third iteration. This represents we are in second iteration. Therefore, if they ask you to find y3, y2 is required as well as y1 required. Y3 depends on previous value. Y2 depends on previous. Y1 depends on y0 value. But in these equations, the unknown things are x1, x2, x3. But x0 is given. So therefore, x1 is given by x0 plus h. x2 is given by x1 plus h. x3 is given by x2 plus h. Like this, xk plus 1 is xk plus h. So when you group this, we are getting x3 equal to x0 plus 3h. Therefore, when you generalize, we get xk plus 1 equal to x0 plus k plus 1 into h, where k start from 0 onwards. Okay. So task is same, but as order increases, accuracy will increase. Note these points. First one, RK method of order 1, that is Euler's method. Consider a first order and first degree differential equation. Consider a first order and first degree differential equation dy by dx equal to f of x comma y. Consider a first order and first degree differential equation dy by dx equal to f of x comma y with initial condition y of x naught equal to y naught. Consider a first order and first degree differential equation dy by dx equal to f of x comma y with initial condition y of x naught equal to y naught and a step size h. We need to find y of x. We need to find y of x where x is a positive integral multiple of h. We need to find y of x where x is a positive integral multiple of h. Where x is a positive integral multiple of h. Where x is a positive integral multiple of h. Therefore, y of 1h equal to this. You write all these points followed by this evaluation and highlight this equation. Note one point. In every iteration, comma, one value is required. In every iteration, one value is required. That is h into f of xk comma yk. In every iteration, comma, one value is required. That is h times f of xk comma yk. That's why it is called RK method of order 1. Next we go to RK method of order 2. Now let us see how RK method of order 2 looks like. See here, this 2 represents in every iteration 2 values are required. In case of previous method, that is RK method of order 1, in every iteration we are evaluating h into f of xk comma yk. If k is 0, that is h into f of x1 naught comma y naught. If k is 0, so here this becomes h into f of x naught comma y naught. Of course, this is required for y1. Suppose if k equal to 1, then this quantity becomes h into f of x1 comma y1. In fact, this is required for y2. Therefore, for every iteration, we need to find h into f of xk comma yk, where k starts from 0 onwards, right? So, we are evaluating single value for every iteration. That's why previous method is called RK method of order 1. Now, in case of RK method of order 2, every iteration requires two values. The first value I call it as k1. k1 equal to h into f of xk comma yk, and k2 equal to h times f of xk comma xk plus h by 2 comma yk plus k1 divided by 2. So you can see, if you want to get k2 value, k1 is required. k1 is common for all. This is h into f of xk comma yk. It is common for all methods. So basically these are called multi-step methods. Why they are called multi-step methods? We are evaluating y values in the different iterations. So RK methods will be also called as multi-step methods. So in every iteration, k1 is required, h times f of xk comma yk, and this is k2, h times increment xk with h by 2 and increment this by k1 by 2. So this is increment by h by 2, increment by k1 by 2. So to get k2, k1 value is required. So once I get k1, k2, the value of yk plus 1 is yk plus delta y. This delta y is nothing but the value of k2. This delta y is nothing but k2. Of course, here k starts from 0 onwards. That means when k is 0, if you start with k value 0, what I get is y1 equal to y0 plus delta y. But actually delta y is k2. So therefore k1 is required for k2. Therefore in every iteration we need to find k1 and k2. Of course you change the values of k from 0 onwards. Therefore this is called RK method of order 2. Okay. So note these points. This. Note this point. Here every iteration requires two values k1 and k2. Here every iteration requires two values k1 and k2. k1 and k2. Hope you understand this. So suppose if they ask you, suppose in the examination, suppose if h value is 0.2. If they ask you y of 0.4, this is nothing but y of 2h. Y of 2h means y2. So to get y2 value, you should know y1 value. So to get y1 value, k1 comma k2 is required. In this case, k value is 0. Now to get y2 value, again k1 comma k2 is required. In this case, k value is 1. That's it. This is the only change. So here y2 is required because h is 0.2. They are asking y of 0.4. So 0.4 is nothing but 2h. That means you need to find y value up to second iteration. So that means in the second iteration you need to find two values k1 and k2. Even in the first iteration you need to find the values of k1 and k2. So to get y1, k1, k2 are required, but in that case index is 0. To get y2, index is 1. Again to get this I must know k1 and k2. So every iteration requires two values k1 and k2. Only thing is you need to start the values of k from 0 onwards. Now let us discuss RK method of order 3. Now in this case every iteration requires three values. So here k1 and k2 are as it is what we have seen for method 2. The same values will be applied in case of order 3 also. k1 is this and k2 is this, and k3 becomes h into f of xk plus h comma yk plus k2. So k1 and k2 are same what we have seen for method 2, and one more parameter is required, that we call it as k3. So h into f of xk plus h comma yk plus k2. See, if I write by 2, I need to write by 2 here also. If it is by 1, then I will divide with 1 only. So therefore in this case yk plus 1 equal to yk plus delta y, where k is ranging from 0 onwards, but here delta y is not k3, delta y is somehow different. This is nothing but 1 by 6 into k1 plus 4k2 plus k3. This is simple to remember. Here we are dividing 6, distributing 6, 1 unit to k1, 4 units to k2, 1 unit to k3, 1 plus 4 plus 1, that is 6. So here why we are giving a major number of units to k2? Because in k2 the increment is very less. So here xk is incremented by h by 2 only, yk is incremented by k1 by 2 only. So increment is reduced by 50%. But here full increment plus h plus k2. Therefore here increment is very less in case of k2. But k1 is okay, k3 is clear. So therefore in this case injustice has been done for k2. So to do the justice for k2, give more units to k2. So therefore in this case k1 is given 1 unit, k2 is given 4 units and k3 is given 1 unit. So therefore in every iteration, so we need to find k1, k2, k3. Note this point. Note, every iteration requires 3 values k1, k2 and k3. Every iteration requires 3 values k1, k2 and k3. So sometimes in the examination they may ask you the increment in y value using Range-Kutta method of order 3. They may use the notation case. So this increment is nothing but this delta y. Instead of asking y3, they may ask you the increment in third iteration. So this is the increment value, delta y. You need to find only delta y. Once you find this k1, k2, k3, you know how to find k1. So if you want to find k1, k2, k3 in the first iteration, k is 0. If you want to find k1, k2, k3 in the second iteration, k must be 1. If you want to find k1, k2, k3 in the third iteration, k value must be 2. So like this we can follow. That is, suppose if h value is 0.1. Suppose if they ask you y of 0.5. This is nothing but y of 5h. So that means you need to find y5. So to get y5, I must know y1. After that I should know y2. I should calculate y3, y4, y5. But to get y1 value, you should find k1, k2, k3. So in that case, the value of k is 0. To get y2, you must find k1, k2, k3. But in this case, maintain the index k value 1. To get y3 also, you need to find k1, k2, k3. In this case, the index value k is 2. Here also the same situation, but index will slowly increase. So k value was 0, 1, 2, 3, 4 like this. This is my problem. Suppose h is 0.1. They may ask you what is y of 0.5. Suppose. See, if they ask you y of 0.5, it is required. Actually, you need to find these much calculations. But in the examination, they may not ask you this lengthy issues. So they may go for, if they go for order 3 or order 4, probably in most of the cases, they might ask you y of h only. That means single iteration is required. So they won't ask you value in third iteration, fourth iteration. If they go for third iteration, probably it may belong to RK method of order 1 only. Okay? It is simply calculation. It is simply a calculation. So if h is 0.1, if they ask you y of 0.5, express this as an integral multiple of h. This is y of 5h. That means you need to find y5. So to get y5, y4 is required. For this y3 is required. For this y2 is required. For this y1 is required. So to get all these y values, you need to find k1, k2, k3. Every iteration requires k1, k2, k3. But in the first iteration, k is 0. In the second iteration, k value 1. In the third iteration, k value 2. In the fourth iteration, k3. In the fifth iteration, k value 4. So please maintain the index carefully. Do the values very carefully. See here, k2 depends on k1. But k3 depends on k2. So carefully evaluate the values. If you go for wrong evaluation of k1, definitely k2 will be wrong. Then whole calculation will be wrong. So be careful with the evaluations of k1, k2, k3, and after that these values. So always the magic is behind evaluating k1, k2, k3 values only. So in every iteration, K1, K2, K3 values are required. 3 parameters are required. That's why it is called RK method of order 3. Now we go to last method. This is RK method of order 4. So in this case, 4 iterations are required. Let us see, the first 2 iterations are same, K1 and K2. But in case of K3, here increment is only h by 2, K2 by 2. And when you go to K4, this is last value. So again, this becomes h into f of xk plus h, comma yk plus K3 only. So therefore, in this case, K4 depends on K3 value, K3 depends on K2, K2 depends on K1 value. So therefore, in this case, the value of yk plus 1 is yk plus delta y. Yk plus 1 is yk plus delta y, where delta y equal to 1 by 6 into K1 plus 2K2 plus 2K3 plus K4. Here K ranges from 0 onwards. K values are 0, 1, 2, 3, etc. So here, in case of K2 and K3, increment is only 50%. Therefore, in case of delta y, measured priority is given for K2 and K3. So K1 is benefited, K4 is benefited. But whereas K2 and K3 are not benefited, so to get the to give the justice for K2 and K3, here we multiply K2 with 2 and K3 with 2. This is 6. How we are distributing 6? 1 unit to K1, 1 unit to K4, and 2 units for K2 and K3. So 1 plus 2 plus 2 plus 1, that is 6. So we are giving, so the formulas are very simple to remember. So this is the way to evaluate y values in RK method of order 4. So in every iteration, we need to find 4 values, K1, K2, K3, K4, right? So therefore, among all these methods, RK method of R4 method order 4 is so effective because it gives value very close to original value, right? Now note all these points. Note, every iteration requires 4 values. Every iteration requires 4 values, K1, comma K2, comma K3 and K4. Every iteration requires 4 values, K1, comma K2, comma K3 and K4, right? Now let us handle 1 or 2 problems based on these RK methods. See, when you go through recent years of GATE examination, frequently they were asking the percentage errors between the original value and the value obtained by RK method of order 1 or 2, 3, 4 like this. Okay, percentage errors. You may get original value, for example 6. When you apply RK method of order 1, you may get value 5.8. Then the error will be 0.2. Then it will be slightly, percentage will be very less. Okay, so they may ask you percentages. If they ask you percentage of error between original and value by RK method of order 1, 2, 3, 4, first you do RK method of order 1 value. If it is the question is given like this, so the method is RK method of order 1. So if they ask you percentage error with the original value and the value by obtaining RK method of order 1, do it by original and then apply RK method, find the difference and apply, multiply with 100, divide with by 100, you will get the percentage error. Okay, this is one of the frequent model. Let us start with an example. Suppose dy by dx equal to 2x plus 1. Suppose the boundary condition is y of 0 equal to 0. This is my equation, dy by dx equal to 2x plus 1, y of 0 equal to 0. And for example, step size is, for example, 0.1. So we need to find y of 0.3. So suppose assume that y of 0.3 is required. Now this is x0 value. Here x0 is 0, y0 is 0 and h value is 0.1. We need to find y of 0.3. So this y of 0.3 is y3h. That means we need to find y3 value. So to get y3 I should know y2. To get y2 I should know y1. This is f of x comma y. So f of, it is a function only in terms of x. Y is not given. So therefore, let us see. Let us apply RK method of order 1. RK method of order 1. So in this case, y1 equal to y0 plus h into f of x0 comma y0. So what is y0? 0. Plus h value is 0.1. What is f of x comma y? 2x plus 1. So f of x0 1. Now let us calculate y2 value. This is y1 plus h into f of x1 comma y1. So y1 is 0.1 plus this is 0.1 into f of x1 y1 is 2x1 plus y. Sorry, this is 2x1 plus 1 because f of x comma y is 2x plus 1. F of x1 y1 is 2x1 plus 1. Answer does not depend on y values. It depends on x values only function. So therefore this is 0.1 plus 0.1 into 2 into x1. x1 is 0.1. So 2 into 0.1 is 0.2. 0.2 plus 1, 0.3. So therefore this is 0.1 plus 0.1 into 0.3. This is nothing but 0.03. So therefore this is 0.13. So y2 value is 0.13. Now x2 is required for next value. So this is x1 plus h. 0.1 plus 0.1, this is 0.2. Now the value of y3 is y2 plus h into f of x2 comma y2. So y2 value is 0.13 plus what is h value? This is 0.1. F of x2 y2 is 2x2 plus 1. So this is 0.13 plus 0.1 into 2 into x2. 2 into x2 is 0.4. 0.4 plus 1, this is 0.5. So therefore this is 0.13 plus this we can write it as 0.1 divided by 2. So this is actually 0.1 is 1 by 10. This is 0.5 is 1 by 2. So therefore this is 1 by 20, 0.05. So therefore this is 0.05. So therefore this is nothing but 0.18. So 0.13 plus 0.05, this is 0.18. So therefore this is y3 value, that is 0.18. So but what is y3? This is y of 0.3. So y of 0.3 we got finally 0.18. Now let us evaluate the original value by differential equations technique. So here dy equal to 2x plus 1 into dx. Variables are separated, go for integration. Integral dy is integral 2x plus 1 dx plus c. So here y equal to x square plus x plus c. So in this case, boundary condition is y of 0 is 0. That is when x is 0, y becomes 0. So replace x value 0, y value 0. So we get c value 0. Therefore this is x square plus x only. So therefore y of 0.3 is 0.3 whole square plus 0.3. So 0.3 whole square is this is 0.3 whole square, 0.09 plus 0.3. So 0.3 whole square, 0.3 into 0.3, 9 by 100, 0.09, this is 0.3. So 0.09, this is 0.3, this is 0.39. So therefore the value is 0.39. But when you go to this, this is 0.18. That is original value, this is 0.18. So therefore the error value is original value 0.39 minus 0.18. So therefore this is approximately 0.21. So therefore the error will be 21%. The error will be exactly 21% because 21% is 0.21. So note this. So in the examination frequently they were asking percentage error. So this is my problem. We were solving this by RK method of order 1. This is my boundary condition, h value 0.1. We need to find y of 0.3. So therefore this is nothing but 3 times h. So we need to find y3 value. When you calculated y1, y2, y3 using RK method of order 1, we are getting 0.18. When you go through regular way, we are getting 0.39. So therefore error is 0.39 minus 0.18. In terms of percentage, this is 21%.